Hello everyone, this is homework 14, equations of lines. We already saw slope-intercept form, so we revisit that and recall the general form of a line contains an x and a y and a constant. Special lines, horizontals, verticals, either x or y is missing. But if we solve for y in the general form in terms of x, so remember this is what we call explicit form. So solve explicitly for y in terms of x. We obtain this special slope-intercept form. And that is an equation, y equals mx plus b, that has a slope of m and a y-intercept of b. And we are now going to use x to graph the line. So if we want to graph using this form, what we could do is plot the y-intercept b, and that's at the point 0b, because remember at the y-intercept the x-coordinate is 0. And then we use the concept of the slope, meaning vertical change over horizontal change, or more simply we'll refer to it as rise over run, to find a second point. So we already know how to identify the slope and the y-intercept. So when you see an equation, fortunately this first one is already given in slope-intercept form, that is everything matches. So the form y equals mx plus b. So we simply extract the slope, which is -5, and the y-intercept b is the constant 3. And it's good practice to say that the y-intercept b is at the point 0 and whatever that value is, in this case the 3, to remind you that that's the ordered pair that lies on the y-axis. So the first thing is to plot the y-intercept. So we go to 0, 3, so 0 in the x, 3 in the y. There's our y-intercept of 0, 3, and then we use the concept of the slope. Now the slope is -5. What you want to do if it's an integer, like it is here, write it as a fraction, put it over 1. So -5 over 1, and then think of it as rise over run. So to get a second point, which is all we need, we're going to rise -5, so that actually means move down 5. Because the rise means your vertical change. If it's positive, you move up. Negative, you move down. So that means we move down 5. 1, 2, 3, 4, 5. And then we run 1. And positive means to the right. Run is horizontal. And that would be our second point. And then we can graph the line. So, trying to be as accurate as I can. Looks like that's the line. And I'll label that as it's given. Y is -5x plus 3. So that's all there is to it. Now, one other thing to point out, though, is this. We thought of this fraction as -5 over 1. You could actually think of this as 5 over -1. That's still -5. And if you think of that as the rise over the run, then from that initial point 0, 3, which was the y-intercept, we can now rise 5, so that means move upward 5, 1, 2, 3, 4, 5, and run -1, so that moves to the left 1, and you could see that that's a point on the graph as well. Okay, so there's a couple different ways to think of that. Here's an example that has a fraction involved, and so it's also missing the constant term. You could think of it as y equals mx plus b, but b is really 0, okay, because it's not there. There is no constant term. I mean, if you really wanted to write plus 0, you could, but it's not necessary. But the fact is that the slope now is 3/5 and the y-intercept b is 0, and that would be at the point 0, 0, actually the origin. So when we go to graph this, we again plot the y-intercept first. That happens to be the origin, 0, 0. And then from that point, we use the concept with the slope again. Now this is a fraction already, so think of it as rise over run. And from that point, the origin, which was the y-intercept, we rise 3, so that moves up 3, and we run 5, so to the right 5, so 1, 2, 3, 4, and that would be our second point. So at this stage, we can now graph the line. And another thing to point out, first of all, let me label it. Another thing to point out is this. You could think of the slope, instead of 3 over 5, I mean, that would be the way I would do it and we're done. But you could think of the slope as a negative 3 over a negative 5. Because that's really the same as 3/5, right? Both are double negatives, make it positive. And so from that point, you could rise negative 3, which means to move down 3, and then run negative 5, which means to move to the left 5. So 1, 2, 3, 4, and 5, and you can see that's another point on the line. Okay, and you can get more if you want. You could actually move from this point, rise 3, and run 5, and you'll be over here. Okay, so you can find more points if you wanted to. But this is just a convenient way to graph a straight line. Now, if it's not in slope-intercept form, like this equation, then you have to obtain y equals mx plus b form. And you could do so in one of two ways. You can think of it algebraically. Let me rewrite the equation 6x plus y is 4. If you want to show it algebraically, we've done this in the past. We're going to isolate the y by subtracting 6x from both sides. And we get that y is equal to, now on the right we cannot combine the x's and the constants, the variables and the constants, we just have to rewrite it. And notice that we have it in the form of mx plus b, so the x is first. So therefore negative 6x plus 4. And that is now in slope-intercept form, where we can determine the slope, which is negative 6, and the y-intercept b is 4 at the point 0, 4. Now, if you prefer, as I've mentioned before, you could solve for y mentally, because remember, it's really just a process of undoing, right? We're going to undo the positive 6x by subtracting. That is, if we start with 6x plus y equals 4, the given equation, and I just want to move the 6x to the right, I'm going to add the opposite, or I'm going to subtract 6x. So I'm undoing the 6x by subtracting, and that gives me y, and when the 6x crosses the equal sign, it changes sign. And becomes minus 6x, and then plus the 4. And again, you can't combine the variables with the constants. So however you get there, we have now the slope is negative 6, y-intercept is 4. At the point 0, 4, let's write the slope as negative 6 over 1. Think of it as run. And at that point, plot the y-intercept first, so I'll label my axes. 0, 4, that would be right there. And now the concept of the slope, rise -6, so from that point, down 6 and run 1, so to the right 1. And that would be another point. And when you're doing these on My Math Lab, it's actually pretty easy because you can count. You'll be able to count the places that you're moving. After you plot your first point, you'll be easily able to count, up or down, how many units, and so on. Graphing tool in My Math Lab. Okay, so I'll label the equation y equals -6x plus 4. Alright, so now to the second page. It says to write the equation of the line with the given slope, m, and the y-intercept b at the point 0b. So remember the form. You couldn't really ask for a simpler question. All it is basic substitution into our equation. Because the general equation, once again, is y equals mx plus b. And so all we're doing is substituting. M is 4. The x and the y stay, they define the line. And you just replace them in the b. And the m is 4. So 4x. And then plus b, and b is 1. Okay, so can't ask for anything simpler than that. It doesn't matter if you have fractions or whatever the case. Again, just substituting into our basic slope-intercept form. So in this equation, again, y and x stay. M is replaced by -8, so -8x. B is a -2/3. There's no need to write plus a -2/3. Most efficiently, just -2/3. So -8x minus 2/3. Here again, substituting. Y would equal mx, so 2/5. The x stays. Plus b is 0. Kind of silly to write the 0. Just give it reported as 2/5 x, y equaling 2/5 x. Similarly here, well, I don't know, maybe the substitution might be nice to show. So y is mx, m is 0, so 0x, plus b is a -5. Again, no need to write plus or minus, we'll just write -5. And although I literally showed the substitution for 0 and for m, the slope, there was no need because 0 times x, of course, is 0. And we just get y as -5. Okay, now here's something algebraically that we're going to need to do. It says to find the equation, my little note you here, to find the equation of a line with given a point and a slope. Point and a slope, we're going to use the following. And there's a definition for what we call the point-slope form for the equation of a line. With a given slope passing through a given point. And so this equation you want to memorize. Now it's very important to realize that the y and the x stay when you are making your substitution to this equation. And I think because my computer's been lagging, I'm going to right there. We will come back and do a part 2 to this lesson.